This is the S2 EDEXCEL June 14R paper. Question 1, we have a null hypothesis, which is the probability of the ball failing the bounce test is 0.2, and the null hypothesis is P is less than 0.2, because the supplier claims that the probability of it failing the bounce test is less than 0.2. The significance level is 5%. Because it's a less than, then it's a one-tailed test. X is the number of failures. So that means that X has a binomial distribution. There's 40 balls being tested. The probability of failure is 0.2. And we need to find the probability that X is less than or equal to 3. So using the tables, we get 0.0285. That is less than 5%. So therefore there is evidence to support the supplier's claim. I think that's the best answer. In the mark scheme it says you can say the probability of a ball failing the bounce test is less than 0.2, but there is evidence to support the supplier's claim, I think, is the best answer. In question 2, part A, the sum of the numbers, yes, that is a statistic because that's just using the numbers in the sample. Part 2, though, mu is an unknown parameter, so therefore that's not a statistic. And part 3, yes, that is a statistic because that's just looking at the numbers in the sample. In part B, t is the variable. It's got a binomial distribution. There's a random sample of 10 and the probability of success is 0.4. So in part C, we need to find the probability of it not being a 2, followed by not being a 2, followed by a 2. So that's 0.6 times 0.6 times 0.4. That works out to be 0.144. In question 3, we have a Poisson distribution. It's 18 in a year, so in 6 months the rate is 9. So in part B, we want the probability that x is greater than 7, which is 1 minus the probability that x is less than or equal to 7. Looking that up in tables, it's 1 minus 0.3239, which is 0.7671. 6761, I should have said. In part C, it's randomly selected month, so 18 in a year, the number per month is 1.5, and we want the probability that y is greater than or equal to 1. It's at least one accident. So that's 1 minus the probability that y equals 0. Looking that up in tables, it's 0.2231, so we get 0.7769. Then in part D, we've got back to a binomial distribution using the result we got in part C. We've got 6 months, and the probability that in any 1 month there's at least one accident is 0.7769. So we want the probability that z equals 4, so that's 6c4 multiplied by the probability of 4 successes and the probability of 2 failures, and that works out to be 0.2719. For question 4, we need to sketch this graph. It's just at 3k to start off with, and then it's part of the curve which does that. That's not part of the answer, so I'm going to delete that, but that's basically what we've got here. So let's put some information on this. This value is 3k, and this value here is 4. Either side of 4 and 0, then it's 0. So we've got this sketch That's k there. That's made things worse. There we go, that's better. And this point here is at 1. Now the graph of kx4 minus x is like this. It's what I had before when I had the little bit in red. It's symmetrical about this point here. That's 4, that's 0, so the midpoint there is 2. So for part B, the mode is 2. It says write down, so it's got to be easy. In part C, the mean is less than the mode. 29/16 is smaller than 2, therefore there's negative skew. In part D, we need to do some integration. So from 0 to 1, we've got 3k, and from 1 to 4, we've got kx4 minus x, and that whole area has to be 1. Integrate 3k, that's 3kx. K is just a fact here. We've got to now integrate 4x, so that's 2x squared. Integrate x squared, that's a third x cubed. And that's between 1 and 4. So therefore 3k times 1 minus 3k times 0. And then we've got k lots of 2 times 4 squared, that's 32, minus 64 over 3. Minus 2 plus a third, that equals 1. So if we simplify that, we end up with 12k equals 1, so k equals 1/12. If you add these together, that makes 9k plus 3k, that's 12k. We have to work out the lower quartile. The lower quartile is such that, let's call that Q1, is such that that area there is 1/4. We know that k equals 1/12. This point here is 3k. 3 times a 12th is 3/12 or 1/4. So we know that Q1 multiplied by a quarter has to equal a quarter. So the area here is a quarter. So length times height has to equal a quarter. It's a quarter because it's Q1, it's a lower quartile. So obviously Q1 equals 1. And now part F, we need to find, we know that the probability that x is between 2 and 3 is 11/36. We need to find the probability that x is greater than 3. There is a way of doing this by symmetry, which is possibly better, but I'm going to do this a slightly longer way. So we have this, we need the probability between 3 and 4. So the probability that x is greater than 3 is the integral between 3 and 4 of 1/12 x 4 minus x dx. So let's integrate that. Integrate 4 times a 12th, that's a third. Integrate a third x, that's a 6th x squared. And then we have a 12th x times x, that's a 12th x squared. Integrate a 12th x squared, and that's a 36th x cubed between 3 and 4. Substitute in those values and we get 5/36.